Okay, let's give you guys some practice. So let's say I've got a piece of wire here of length 1. So this is my wire here of length 1. I'm going to cut it. Let's just say I'm going to cut it here. So I will have one piece of wire here and another piece of wire here. Now with this piece here, I'm going to bend it here, and bend it here to create a perfect square. And with my second piece here, I'm going to bend it here, bend it here, bend it here to create a perfect to create a perfect square here. So this here has an area of 1. This here has an area of a2 here. So the overall the overall area will be the sum of the two areas here. So a1 plus a2. The question is, looking at my wire here, where should I cut the wire in order to produce this biggest area here? In order to optimize, in order to give me the biggest area here. Okay, so where should I cut the piece of wire here to give me this biggest area here? Okay, so press pause and have a go. Okay, so if you think about it, if you cut the wire here, let's say, so this length is x, and then this length will be 1 minus x. Okay, and then, well, if this is x here, then this length here will be x over 4. This length here will be 1 minus x over 4. Okay, so this area here will be given by this. Okay, and then this area here will be given by this. So now we've got a formula for our area. This is what we're interested in. We want to create the biggest area here. So x is varying about, x is sliding back and forth. Okay, and this is what we're interested in. We're trying to optimize this. We're trying to make it the largest possible. Okay, so this is our formula here. Let's just rearrange it. Blah blah blah. This here can also be written as this. Hang on. So it's blah 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 blah. It can also be written as this. Okay, so hang on. This here can also be written as this. Okay, so now we've got a well, if you look at this, let's try and plot a graph of this. So now we've got area. This is our area equals this whole thing here. Now if you look at this here, this is really a quadratic here. So let's try and sketch it. So when x is small, it wants to do this straight line here, and when x is big, it wants to do a positive quadratic here. So when x is small, your eyes should zoom into the intercept. So when you try and sketch this, zoom into the intercept. That's this bit here, and then looking at this, it wants to do a negative gradient, where the gradient will be 1 over 8. So it's going to be a very shallow gradient because the up and down will be 1, the across will be 8. So it's very shallow. Okay, so our line here, intercept of 1 over 16, it should be a shallow gradient. Okay, shallow gradient. And then when x is big, it wants to do a positive quadratic. So we want to well, hang on. So it would be a positive quadratic, something like this. Okay. Hang on. Let me just exaggerate a bit. Hang on. So it wants to do a positive quadratic. So our graph will look something like this. Okay. Our graph will look something like this. So let's try and investigate this bit here. This point here. So now we've got a graph of area versus x. So here we've got a graph of y versus we've got a graph of a versus x here. All we care about is well, we want to find out where the gradient will be 0, where the gradient will be 0. So let's just differentiate this. So hang on. So at the moment we've got a formula for area versus x. So we've got area and then x over here. So well, if you want to find out where, well, here we've got a graph here of a versus x here. We just want to find out where the gradient will be 0. So what we do is looking at our equation here. If you want to find out where the gradient will be 0, just differentiate it. So differentiate a here with respect to x. So that will then give us this here. Now this is quite strange here. What does it mean to differentiate a with respect to x? So this is you differentiating a with respect to x. But what does that mean? The thing is, the thing is, we don't care what it really means, because all we care about is, at the moment, we've got a graph of a versus x, and we just care about where the gradient is 0. So basically we just want to know where the gradient is 0. So we just differentiate a with respect to x, if that makes any sense. So it is quite strange that we are differentiating a with respect to x, and it's quite hard to grasp what this really means. But the thing is, we don't really care, because it's just a graph of a versus x here, and we just want to know where the gradient is 0. So let's just find the gradient. Let's just find the gradient. Okay. So that will then give us this here. Okay. I will continue in the next video. Okay.